Hello, my name is Ravi Hadimani. I'm a faculty at Mechanical and Nuclear Engineering of Virginia Commonwealth University. Um, I'm also the director of Biomagnetics Laboratory. So the main research focus of Biomagnetics Laboratory is the biomedical devices, and specifically we are focusing on a technique called transcranial magnetic stimulation. So transcranial magnetic stimulation uses short pulses of magnetic fields to stimulate specific part of your brain, and by doing that you can reduce symptoms of really serious neurological or brain diseases or disorders. So one such disorder is Parkinson's, or one such disease is Parkinson's disease. So in Parkinson's disease, people get tremors. That's because their motor pathway network in the brain is not working very well. So the neurons where they are supposed to fire at certain frequency are not firing. So what we do is, with this technique called transcranial magnetic stimulation, we are trying to stimulate these neurons to make them fire at the required frequency. And of course it's a complex network, and we are looking to study the neurons in all the parts of this network. And to do that we have to design new coils, which needs the knowledge about magnetic fields, how to generate them, how to limit them, and also it needs knowledge about the network of the motor pathway in the brain. So we design magnetic coils, and also we measure the effect of magnetic coils on the brain phantoms. So we use magnetic coils and see where the currents go. So by knowing where the currents go, we come to know whether the neurons in that part of the brain will get excited or not. And we measure the currents in the brain using electrodes, by putting the electrodes inside. And we make this brain phantom from MRI images. MRI stands for magnetic resonance image. So using MRIs, we build these brain phantoms that resemble the electrical properties, electric and magnetic properties of different parts of your brain. So by doing that, we can measure the stimulation strength in all the critical areas where we need to make the neurons fire at required frequencies. So we think that TMS has a lot of potential to not only treat Parkinson's disease, but also treat many other neurological disorders. It is already FDA approved for treating depression and migraine and obsessive compulsive disorder. So we are developing better coils and more specific coils to treat other disorders.
We have been working with models of a realistic and anatomically accurate human head. So basically, these models allow us to perform studies taking into consideration the different layers of the brain and their electromagnetic properties. So based on that, we are able to test different coils that we are developing, so that we can stimulate very specific points in the brain cortex, as you can see here. So this is the detail of one of our stimulation targets, and this is going to allow us to develop better treatment for several neurological conditions and psychiatric disorders, as Dr. Hadimani has mentioned.
So the human brain is unique, and the brain structure varies significantly from one person to another person. So when we want to design new coils, we have to take into account this variation. So we build a lot of head models from MRIs of many patients. If you see here, the brain models that we have developed from MRIs of many patients, you can see there is a large variation in the brain anatomy. So we need to take into consideration of all these variations, not just in anatomy but also the functional variations into account when we are designing new TMS coils. And if you see on this side of the screen, you see how complex is a motor pathway network in human brain. So there are multiple brain regions that are involved in enabling the motion or in enabling movement in a person's brain. So we need to make all these regions in the brain function properly in order to treat motor neuron diseases like Parkinson's disease or dystonia. Thank you.